Hey guys, so in this video we are going to look at some sample problems where we apply the force mass acceleration method. Okay, so for our first example, the 200 Newton block A is at rest on the horizontal plane when the 300 Newton force P is applied at t equal to 0. Find the velocity and position of the block at t equal to 3 seconds. So the coefficients of static and kinetic friction are 0.2. Okay? So yung given dito sa problem na to is yung force and then hahanapin daw natin yung velocity and position ng block after 3 seconds. So to obtain that, kailangan natin makuha yung acceleration ng block natin. So we need to relate the force and the acceleration. Ibig sabihin, yung equations of motion lang yung gagamitin natin. So first, both the free body diagram and the mass acceleration diagram should be drawn. Here in our free body diagram, since a coefficient of friction is given, this means that our object is moving on a rough surface. Therefore, it is necessary to use the frictional equation F equal to mu times N, where mu is the coefficient of friction and then yung N naman is the normal force. Okay? So this equation relates the frictional and normal forces acting at the surface of contact. Always remember that the frictional force acts on the body such that it opposes the motion of the object relative to the surface it contacts. So in this example, yung force natin is to the right, so we should expect our body or our block to move to the right then. Ibig sabihin, yung frictional force natin will counter that. Okay? So opposite yung direction niya. So therefore, yung frictional force natin will be acting towards the left direction. So we will also have the normal force here. So tatandaan nyo yung normal force that is always perpendicular to the surface of contact. So in this case, it will be acting vertically upwards. And then of course, nandito din yung force P natin. So it will be acting on this direction. And then of course, yung weight ng object natin. So that will be vertically downward. Okay? So you should be able to identify these forces immediately. Dahil nadaanan nyo na to dati sa statics nyo. Okay? So ito na part, itong free body diagram, similar pa ito sa statics. So ngayon, dahil dynamics yung pinag-uusapan natin, we also need to draw the mass acceleration diagram. Again, our block and then yung direction ng inertia vector natin, dito natin makikita sa mass acceleration diagram. So in this case, again, we expect our block to move horizontally to the right, so the direction of our inertia vector will also be to the right. And then of course, don't forget to indicate your coordinate axis clearly and then yung positive directions niya. So in this case, all values along x that are going to the right will be positive and then lahat naman ng values along y that is upward will be positive. So now, referring to the free body diagram and our mass acceleration diagram, we can formulate the following equations of motion. So along the x direction, we have summation of forces along x equal to max. Again, taking positive values to the right, we have this equation, p cosine theta minus our frictional force equal to ma. And then, recall that our frictional force, that is equal to the coefficient of friction multiplied by the normal force. And then yung mass natin, since yung given sa problem is weight, so we will express that in terms of our weight. So mass that will be equal to the weight divided by the acceleration due to gravity. And then next, along the y-axis naman, we have these forces. The normal force, which is acting upwards, ibig sabihin positive siya, minus our weight, and then minus the vertical component of our given force. So minus p sine 30. So recall that our object will only be moving along the horizontal direction. Hindi siya gagalaw along the y direction. Okay? So hindi naman lilipad yung block natin upwards. Tama ba? Ibig sabihin, yung acceleration natin along y will be equal to 0. So we can just equate our forces along y equal to 0. Now, if we substitute the given values here, so we will have the normal force minus yung weight, so that is minus 200 newtons, minus yung value ng P, which is also given, that is 300 newton. So from this equation, we will obtain the value of our normal force, and that will be equal to 350 newtons. And then, we can substitute this value doon naman sa kabilang equation natin. So again, we will have 300 cosine 30 minus the coefficient of friction, that is 0.2 times 350, yung normal force natin. And this will be equal to the weight, 200, divided by acceleration due to gravity na 9.81 times our acceleration. So solving for A, we will obtain the value of our acceleration equal to 9.31 meter per second squared. So ngayon, meron na tayong value ng acceleration. Pero recall na yung hinahanap sa problem is yung velocity and position ng block natin, hindi yung acceleration. Okay, so we need to find a relationship between acceleration and then yung velocity and position. Hopefully, hindi nyo pa nakalimutan. So from our kinematics, the velocity v of the block can be solved from the definition of acceleration that we have discussed on our previous video. So acceleration, that is equal to the first derivative of our velocity with respect to time. Pwede natin gawin dito is we can separate our variables and then we can integrate both sides. We now have an equation for our velocity in terms of our acceleration. It will be v equal to acceleration times time plus our constant of integration c1. And then similarly, the position coordinate can also be solved from the definition of velocity. So recall that our velocity, that is equal to the first derivative of our position vector with respect to time. So again, we can just separate our variables here and then we can integrate both sides. So now we have an equation for our position in terms of our acceleration. So that is x equal to at squared over 2 plus c1t plus c2. Okay, so the constants of integration c1 and c2 can be found from the initial condition. So since the block is initially at rest, hindi siya gumagalaw, yung initial velocity niya is equal to 0. Therefore, we have the initial condition v equal to 0 at t equal to 0. So we can just substitute this initial condition dito sa equation ng velocity natin and then we can solve for c1. So the value of our c1 is actually 0 then. So next, we can obtain the value of our second constant of integration from the initial condition x equal to 0 at t equal to 0. So if we substitute that to our position equation here, we will obtain the value of c2, which is also equal to 0. So now we have these equations for our velocity and position. At time t equal to 3 seconds, bali isa-substitute lang natin yung t equal to 3 dito sa velocity equation natin. And then yung acceleration that we have found earlier, we can obtain the value of the velocity of our block at t equal to 3 seconds, and that will be equal to 27.93 meters per second. And then similarly, for our position vector, at t equal to 3 seconds, so we will just substitute the values for our acceleration and time. And now we have the value of our position after 3 seconds, and that will be equal to 41.9 meters. So therefore, at t equal to 3 seconds, our block will have a velocity of 27.93 meters per second and a position equal to 41.9 meters. Okay? So, take note that if our solution for our unknown vector component yields a negative sign, it indicates that the component acts in the direction opposite to what was initially assumed. So, in this case, positive values naman yung nakuha natin. So, ibig sabihin, tama yung assumption natin that our block is moving to the right. So, for our next example here, when the 1.8 kilogram block is in the position shown, the attached spring is undeformed. If the block is released from rest in this position, determine the velocity when it hits the floor. So the first thing that you should do is to draw the free body diagram and the mass acceleration diagram of our object. So here in our free body diagram, we have two forces acting on our object. First is the weight of our block, so that is vertically downwards. And then, since the block is connected to an elastic spring, meron tayong spring force present dito that is acting upwards. The spring force P sub S can be related to the deformation of the spring by the equation P sub S equal to Kx. So in this equation, K is the spring's stiffness measured as a force per unit length. And then yung X naman is the stretch or compression defined as the difference between the spring's deformed length and undeformed length. So again, hopefully hindi na bago sa inyo itong spring force na to. I'm sure nadaanan nyo din ito sa statics nyo. And then for our mass acceleration diagram, we have our block and then yung direction ng inertia vector natin. So we will just assume that it will be going downwards. It makes sense naman siguro na our object will be moving pababa. And of course, don't forget to indicate your coordinate axis and then yung direction ng mga positive values natin. So in this case, yung gagawin natin, yung X naman will be vertical. So lahat ng forces that are going downwards, that will be positive. And then yung Y naman natin, gagawin nating horizontal. From our free body diagram and mass acceleration diagram, we can formulate the following equation of motion. So along the x-axis, again, x natin is vertical and then positive downwards. So we have summation of forces along x equal to ma. So the forces along our x direction, that will be weight. So positive yung weight natin kasi pababa siya. And then minus the spring force P sub S equal to mass times our acceleration. So we can only formulate an equation of motion along the x-axis kasi along the y-axis, wala naman tayong forces present doon. From this equation, we can solve for A and obtain this value for our acceleration. So kung mapapansin nyo, yung value ng acceleration natin depends on the elongation of the spring X. So as our block moves downward, syempre mag-i-stretch din yung spring natin. Okay? So ibig sabihin, magkakaroon siya ng elongation dito. But take note that as our block is moving downward, yung value ng elongation na to or ng stretch na to, nagbabago din. In other words, yung elongation ng spring natin as the block is moving downward is not constant. Ibig sabihin, yung acceleration natin dito is also not constant. Nagbabago din siya. Katulad ng x natin. Or ng x ninyo. Charlotte. So again, the problem asks for the velocity of our block when it hits the floor. So, kailangan natin ng velocity. Meron tayong equation for acceleration. Therefore, we need to relate these two values. So again, yung acceleration natin dito is in terms of our x. Ibig sabihin, this relationship will be much more useful. So acceleration, that is equal to v times dv over dx. So we will just separate our variables here, and then we will substitute the value of our acceleration in terms of x, and after that we will just integrate both sides. So we now have the equation gx minus kx squared over 2m plus c equal to v squared over 2. The constant of integration can be eliminated from our initial condition. So recall that our block is at rest o hindi siya gumagalaw at its initial position. And then, initially, yung spring din natin is undeformed. So, hindi pa siya na-stretch. So, we have x equal to 0. So, if we substitute this into our equation here, we will obtain the value of our constant of integration, and that will be equal to 0. So, again, back to the problem, hinahanap natin yung velocity when it hits the floor. Ibig sabihin, yung value ng x natin dito will be equal to 0.3 meters. So we just substitute our known values. We have 9.81 times 0.3 minus our spring constant. So that is 80 Newton per meter times x ulit squared over. Okay, so dapat merong 2 dito sa baba. Tama, sa integration natin kanina, that should be x squared over 2. So over 2 times the mass of our block, that is 1.8 kilograms, equal to v squared over 2. So solving for v, we will have the value 1.37 meters per second. Therefore, the block will have a velocity of 1.37 meters per second when it hits the floor. Okay, that's it. Again, recall na yung mga ginamit natin kanina na equations, hindi na yun bago sa inyo. So, equations of motion, summation of forces equal to ma, and then yung definition or relationships between velocity, acceleration, and then yung position natin. So, yun lang naman yung tatandaan nyo in order to solve these types of problems. Okay, so thank you guys for watching. See you on the next video.